So we're going to move on to the last section of this chapter. So as I said, I don't know if you were class yesterday or on Tuesday. If you weren't, I decided we're skipping Unit 7, Section 5A, and Unit 7, Section 5B. We're skipping that one. I want to keep moving on so we can get through as much, so we can get on to the next chapter and get through as much as that as possible before the end of the year. So we are going to be starting on trapezoids. You can cut out those pages that we're not using if you'd like, whatever you want to do with those. So we're going to be moving on to Unit 7, Section 6, trapezoids. Okay, so first off, trapezoids, if you don't know the definition, it's a four-sided flat shape with straight sides that has a pair of opposite sides that are parallel. So on that first box right here, only one pair of opposite sides is parallel. This is not just true for non-isosceles triangles. This is true for all trapezoids. I think I said triangles. Non-isosceles trapezoids. It's true for all trapezoids. It becomes important in non-isosceles trapezoids. So non-isosceles trapezoids also have consecutive angles between parallel lines that are supplementary. So what that means is, here's my parallel lines, my two parallel lines on my trapezoid. I guess I should go into, I forgot to say, the two parallel lines are what we call bases of a trapezoid. The other two sides are the legs of a trapezoid. It's important to know these because some of the questions are going to mention this information, and I want you to make sure that you know what those mean. So consecutive angles between parallel lines are supplementary. Okay, remember, consecutive angles are the ones if I have, I'm just going to draw this up here real quick. If I have my two parallel lines cut by a transversal, remember that's the two that are on the same side of the transversal, and they are supplementary. So if this right here, this leg, were my transversal and my two parallel lines, that means these two angles are supplementary. It also means these two angles are supplementary. So that means they add up to 180. And that's about it as far as non-isosceles trapezoids. Isosceles trapezoids have the same properties as non-isosceles trapezoids. So same thing, only one pair of opposite sides is parallel. And consecutive angles between the parallel lines are supplementary, so these two, though they add up to 180. They also have these properties. So non-parallel sides, so the legs, are congruent. So this is one leg, this is another leg. Those are congruent. Also, the diagonals are congruent. So here's one of my diagonals. And here's the other diagonal. Those are also congruent. The base angles are also congruent. So base angles means the two angles along each base. So those two angles are congruent, and these two angles are congruent. The last thing is the opposite angles are supplementary. So that means these two angles.
Jeannie Higgins, please report to the office. Jeannie Higgins, please report to the office.
There's not even school today. Why are they making announcements? Good grief. Okay. So that means these two angles are supplementary, and these two angles are supplementary. So, let's look at number 1. So this is a non-isosceles trapezoid, and we know that one, since it's not given to us, we know it's a trapezoid because I have two opposite sides that are parallel, but we don't know, obviously looking at the picture, we're pretty positive it's a non-isosceles trapezoid. However, if we're not given that these two sides are congruent, then we can know for sure that it's a non-isosceles triangle. So, I want to find the measure of angle K, which means it is, since the on non-isosceles trapezoid, consecutive angles between parallel lines are supplementary. So that means angle K and angle L are supplementary. So I can take 180 minus 51, and that's going to give me 129. So the measure of angle K is 129 degrees. Then the measure of angle M, same thing. Angle J and angle M are congruent, or not congruent, supplementary. So 180 minus 87 is going to give me angle M, which is 93. So angle M is 93 degrees. So pretty simple. On number 3. So, again, here's my parallel lines. They don't always have to, our drawing doesn't always have to be up and down. It also always doesn't have to look something like this. We're used to seeing trapezoids looking like this. However, they don't always look like this. This is still a trapezoid because it has two parallel lines, two opposite parallel sides. That's what I mean. So remember, again, consecutive angles between the parallel lines are supplementary. So that means 8x plus 6 plus 54 equals 180, because those two angles are supplementary. So I'll let you finish solving for x. Okay, so that's pretty much it for non-isosceles trapezoids. Pretty simple stuff. So let's look at number 5. So if D, E, F, G, so this is another way we can tell if it's an isosceles triangle. If they give us the statement that it's an isosceles triangle or a non-isosceles triangle, we can use that to determine which one it is. So I'm trying to get out. So if D, E, F, G is an isosceles triangle, that means that DG is congruent to EF, because remember the legs are congruent. So DG is congruent to EF. And also, my diagonals are congruent. So DF is congruent to EG. And that's it. On number 6, again, if TUVW is an isosceles trapezoid, remember up here it says the base angles are congruent. That means that angle T and angle U are congruent. So angle T is congruent to angle U. And angle W and angle V are congruent. So angle V is congruent to angle W. So that's it. So go ahead and use these properties. I want you to go ahead and do 7 and 8. Also do 2 and 4 on this page, and then finish number 3. If we flip it over to the back of this page, we have a little bit of practice here. So if MNOP is an isosceles triangle, or trapezoid, God, I keep saying triangle, that means this side is congruent to this side, and it also means my diagonals are congruent. So I'll get there in just a second. So if MP equals 16x minus 13, and NO equals 9x plus 8, those are congruent. That means I can set them equal to each other and solve for x, which is what it wants us to do. It wants us to solve for x. And then we also we want to solve for y using Pn and Mo. So Pn, switch colors here. So Pn is this one right here. That's a diagonal. And Mo is this one right here. That means those two are congruent as well. So if Pn equals 5y plus 19 and Mo equals 12y minus 37, minus 37, since those diagonals are congruent, again, I can set them equal to each other to solve for y. So I'll let you guys go ahead and finish that one on your own. Solve for x and y. Okay, if I look at number 10, ABCD is an isosceles trapezoid. I want to find each missing angle. So since this is an isosceles trapezoid, that means my base angles are all congruent. So that means A and B are congruent, and D and C are congruent. So to find the value of x, I can set C and D congruent to each other, or equal to each other, and solve for x. Once I have x, I can plug that into both C and D, find the measures of angles C and D, and then I want you to think about how you can use that to find the measures of angle A and B. Okay. So I'm going to let you guys run with 11 through 14. Pay attention. Use those properties on this front page here. Okay, pay attention to these. All of the ones on the back deal with isosceles triangles. So, and I think they're all finding angles, right? Yeah, they're all finding angles. So that means is you're going to use these. Oops. Those and this one here. You're going to use those three properties. So if you get stuck, refer back to those. So go ahead and finish, or do 2, finish 3, do 4, do 6, 7, and 8, or sorry, 7 and 8, and then finish 10, or finish 9 and 10, and then do 11 through 14. Okay? Then we also have this kind of little extra part of trapezoids, and that's what we call the mid-segment of a trapezoid. So a mid-segment of a trapezoid connects the midpoints to the legs. So that's saying if E is the midpoint of AD and F is the midpoint of BC, then EF is what we call the mid-segment of this trapezoid. Okay, so if EF is the mid-segment of trapezoid ABCD, then we know two things. We know that AB is parallel to CD, which we already know because it's given, and all trapezoids have the bases are parallel. But we also know then that it's parallel to EF. So we know that all three of those, well, those two sides and that mid-segment are all parallel to each other. We also have this formula we can use to find the length of EF. So EF is equal to AB plus DC. I wrote this one backwards. It should technically be written DC. So AB plus DC divided by 2 is going to give me EF. So if I'm trying to find the length of EF or I'm trying to find the length of one of the bases, I can use this formula. EF equals AB plus DC divided by 2. So if we look at number 1, if AB is 14 and DC is 26, find EF. So all we do here is plug these values into that formula we just made, or we just found out. So I'm trying to find EF. It is equal to AB, which is 14, plus DC is 26, divided by 2. So if you do your math, 40 over 2, that means EF equals 20. So that's the length of EF. And that's it. Pretty simple stuff. Sometimes we're given different pieces of information. We're just using algebra here. So if EF is 22 and DC is 38, we want to find AB. I'm looking at number 3. So EF this time is 22 equals AB, we don't know that, plus DC, which is 38, divided by 2. And again, I just do my math. I can multiply both sides by 2. 44 equals AB plus 38. Subtract 38 from both sides. And AB equals 6. It's as simple as that. Okay, so I'll go ahead and let you do 2 and 4 on your own. I want to look at number 5. So for trapezoid PQRS, if Y and Z are the midpoints of the legs, so here's my legs, and my legs. If Y and Z are the midpoints, that means YZ is my mid-segment. So my mid-segment, in this case, is YZ, is equal to 38, oops, I'm going to just write it out with the variables first, PQ plus SR divided by 2. So I'm going to sub everything that I know into there. So YZ is 5x minus 19, which is equal to PQ is 38, plus SR, which is x plus 14, all divided by 2. All I do is start simplifying. So if I multiply both sides by 2, remember I have to multiply this whole thing by 2, so use your distributive property. (10x minus 38 equals, I'm going to go ahead and combine 38 and 14 here, equals x plus 52. Then I keep solving for x. So minus x, 9x minus 38 equals 52. Add 38 to both sides. 9x equals 90. So x equals 10. Okay, but I'm not just trying to find x, I'm trying to find yz. So I use x, I plug that in for yz, and I can find, or I plug that in, to 5x minus 19. And I can find the length of YZ. So go ahead and finish that one up. Yeah, and then 6 and 7 are the same as 5. So go ahead and finish 5, do 2, 4, 6, and 7. That is all I have for trapezoids. If you notice on the back of, oh, I didn't put it in here. On the back of the last trapezoids page, there's a quadrilateral properties cheat sheet, which talks about all of the different properties of the shapes. So on the left side talks about both the properties of trapezoids and isosceles trapezoids. And then on the right side it talks about the properties of parallelograms, which then leads to the properties of rhombi and rectangles. Remember, rhombi and rectangles have the same properties as parallelograms, and they have additional properties for themselves. And then which leads to squares, which have all properties of parallelograms, rectangles, and rhombi combined. So just a little cheat sheet for you there. Go ahead and keep working on that study guide. You're going to do topics 1 through 6. You're going to skip topic 7 and then do topic 8. Since I skipped the section that's topic 7, we're going to skip it, and then you can do topic 8. And then that's it. We're done with this section, so we'll start reviewing, and then we will take a test. That's it. That's all I have.